Okay, we've got this tall building here. We've got a fence running parallel to the wall of that building that's 3 feet high and also 3 feet from the wall of the building. And we want the length of this ladder from the ground to touch the building. We want the shortest ladder. So if we label the unknown lengths, this is X, the distance from where the ladder touches the ground to the base of the wall of the fence. Y is the height on the building where the ladder touches the wall, and Z is the length of the ladder. So by right triangle, or by similar triangles, 3 is to X as Y is to X plus 3. And that implies that Y equals 3X plus 9 over X. And the length of the ladder by the Pythagorean theorem is the square root of this leg squared plus this leg squared. But Y squared, Y is replaced by 3X plus 9 over X. There's your function, Z, depending on the length of X, how far from the fence we place the base of the ladder. If we could find the derivative of Z with respect to X, set it equal to 0, we'd have the critical number, and we think that that probably gives us a minimum. Here's the original function using the square root symbol instead of a fractional exponent. G prime is this graph right here. Here's the derivative where we applied the power rule followed by the chain rule. Hopefully you can follow along there with the algebraic simplification. Here's some steps to reach this numerator. And that numerator is only equal to 0 when x equals -3, which we reject, or when x cubed equals 27 or x equals 3. And it turns out that g of 3 gives us this 8. That's the length of the ladder right there, the shortest ladder. Here's the graph. And you can see from that graph that that's the minimum length of the ladder. Anything else gives us something greater. Of course, you'd have to apply first or second derivative tests to show that that's a minimum, but we'll leave that to you. There you go. Hope that helped. If you have any questions, post a comment.